Hello, Angelo. I think your number 2 has got a eigenvector that looks like this. I on top and 1 on the... That's the eigenvector. All right. Now, by definition, of course, if you put the operator for this eigenvector on it, some operator S question mark on this eigenvector, then you should get some eigenvalue. I'll just call it, actually, let me do it right and call it lambda. That's what you guys call it, right? Lambda. You get some eigenvalue, and then you get the psi back. I mean, you're supposed to get the psi right back. That's how operators and eigenvalues work. So I thought, hey, why don't we just, so they just told us, hey, you're going to use sy, sz, sx, so why don't we just test them all? I mean, it's only 3 of them, so let's just test them all. So my way of doing this was just getting these as matrices, nice little matrices here. This is supposed to be a z. This, for the z, it's 1, -1 on the diagonal, and then zeros. And then for the y, it's 0 as diagonals and -I and I off the diagonal there. And for the sx, it's 1, -1 on the diagonals and 0. Oh, sorry, that was sz. For the oh, my bad. For the for the sx, it's zeros on the diagonals and just 1s off diagonal. Okay, so I'm going to test them all. So I'm going to go sx operating on the psi is h bar over 2, and there it is. That's the sx. That's a 0, and the psi is this guy. Just copying it down from there. Now, these constants can just, these scalars can just leave. So this is going to be equal to h bar over 2 root 2. But I'm going to do just matrix multiplication here. So first row here is first row times this whole thing, and the 0 times I plus 1 times 1, that's just 1. And then second row here is second row times this whole thing, 1 times I plus 0 times 1, which is 0. Okay, so this right here, this is not that. Right? So that's how I'm concluding that sx is not our operator. Right? Now I tried sy and I tried sc. I got the same. I got a non-match for sz, but I got a match for sy. And here's what I got for sy. I ended up with that h bar over, I had a h bar over 2 like this, and then I had -I and -1 like that, alright? So that's just the same as pulling this out as -1 as a scalar, so that's -h bar over 2, and then I'm going to rewrite this root 2 in the denominator as a 1 over root 2, just so I can get maximum resemblance. So this guy is exactly psi, right? So that's how I conclude that sy is the operator that we are looking for, and -h bar over 2 is its eigenvalue when operating on the psi. And I'm gonna end this video right now.